Hey, it's Mr. Warren here with another example problem from exercise 8.1, talking about linear functions. All right, this problem says the table shows the temperature of a cup of hot tea that is left on the table over a period of 9 hours. So what does this table say? Well, every entry in this table gives us a time and a related temperature. So this first one, and I'm going to write these as ordered pairs, says that after 0 hours have passed, that means as soon as we put down the tea, the temperature is 96 degrees Celsius. This entry in the table says that after 3 hours have passed, our tea is now 69 degrees Celsius. After 6 hours, our tea is 42 degrees Celsius. And after 9 hours have passed, our tea is 15 degrees Celsius. Okay, so our tea is obviously cooling down over time. And our first problem is they want us to draw a graph to represent the data. So we're going to take these 4 ordered pairs, we're going to plot them as points, and then we're going to look for a pattern. So let's go over here to GeoGebra. I'll go ahead and put these in here. 0, 96 was our first point. Our next point was 3, 69. Then we had the point 6, 6, 42. And the point 9, 15. And there we go. Those are our 4 points of data. And does it look like it's a linear relationship or a linear function? Let's see if I connect these two. Yeah, these other ones are on the line as well. Okay, so we've got a linear function here. Let's go on to the next question. So we're done with this. We drew the graph, we connected it with a line, and now we have a graph to represent the data. Find the rate of change of this function and explain what it represents. Okay, let's look at this. Let's go ahead and move this just a little bit so I have some more space to draw. Now, first of all, this is a linear function, and a linear function, as we know, makes a straight line, but more importantly, a linear function has a constant rate of change. That means that as our time goes on, let's try that again. I just want to go from here to here. That means as our time goes on from A to B, our temperature decreases by the same amount, okay? So this actually represents, so let's see, this is the point 096, and this is the point 369. So this represents 3 hours of time that has passed. And what happens to our temperature? It goes from 96 degrees to 69 degrees. That is a difference of 27 degrees. So our temperature went down 27 degrees in 3 hours. And because this is a linear function, every 3 hours, our temperature is going to go down by 27 degrees. So let's write that as a rate. For every, let's say, we lose 27 degrees of temperature every 3 hours. Now we can simplify this, make it into a unit rate. And what do you get? Well, you get -9 degrees Celsius per hour. Our tea is losing 9 degrees, or our tea's temperature is going down 9 degrees Celsius every hour. And that answers the next question right there. That would be the rate of change. Our rate of change is -9 degrees Celsius for every 1 hour. Is this function increasing or decreasing? Well, it's going down as time goes on. Our tea is getting cooler, so this is definitely a decreasing function. Answers that problem. This is decreasing. Find the initial value of y. The initial value is when x equals 0. This right here is going to be, that point is going to have our initial value of y. And remember that that point, let me go ahead and clear this up a little bit. There we go. Now this point had has coordinates 0, 96. That means as soon as you set the tea on the table, it has a temperature of 96 degrees Celsius. And that answers our question here. Our initial value was not 69, 96 degrees Celsius. Okay. Express y as a function of x. Okay, let's do that. I'm going to clear this screen out. Now, remember that every linear function can be written in this form. Y equals mx plus b. Now, m is equal to the slope of our function, and slope is our rate of change. We know from this, oh, not this one, actually, it was b, that our rate of change is our temperature is going down 9 degrees. So our slope is going to be m is equal to -9. Every hour, our temperature is going down 9 degrees. Now, the b is our y-intercept. And that is our y value when x is 0. Oh, well, I know that our y value when x is 0 is 96. So I'm just going to take those two numbers and I'm going to plug them into our expression. Our b is equal to 96. Okay, so I'm just going to plug m and b into our general expression for a linear function. Y is going to be equal to, our m is -9, so -9x plus our initial value, or our y-intercept, which is 96 degrees. Written another way, you can see that our temperature of our T is 96 minus 9 times x. It starts at 96 degrees, and every hour, that's every hour is our x, we're going to lose, our temperature is going to go down by 9. So either one of those is correct. You could say -9x plus 96 or 96 minus 9x. It's the same thing. And that answers our last question. All right. If you have any questions, put them in the comments. Take care. Bye.